G'day guys, we've got a uniform distribution question today. Let's just go through it quickly. The length of time Daniel is late to class is modelled by a uniform distribution with a minimum late time of 5 minutes and a maximum late time of 25 minutes. Define T, the length of time Daniel is late to class. Okay, so a uniform distribution. So if we just quickly draw a snapshot of what this looks like. We've got our axes here. A uniform distribution is literally, for this one anyway, it's just a straight line. So there's no difference in the probability of any one thing occurring. So what we can do now is we're going to define this function from here to here. So from 5 minutes being the minimum to 25 minutes. And we know that the area of this has to equal 1 because the probability of everything happening is equal to 1. So we have a distance from 5 to 25 of 20. It has to equal 1. So the height of this must be 1 over 20, if that makes sense, because the area of a rectangle is length times width. If the length is 20, the area is 1, the width must be 1 over 20. Okay, so now let's get straight to the question. So for A, it says write the probability density function for T. So we're looking for the function of T. Now, the function of T isn't really dependent on what T is going to be because it's 1 over 20 all the time. So we don't have to include T in our function. So it's just going to be 1 over 20. Now we have to make sure we have to define this for a particular domain. So this is defined from 5 up to and equal to T up to and equal to 25. So our function isn't dependent on T. It's just 1 over 20 all the time on this domain here. So there, that's basically it. Let's go on to the next part of the question. B. Find the probability that Daniel is exactly 15 minutes late. So probability that the time is late is equal to 15. Now this is a sort of a trick question. If I looked at the marking guide for this sort of question in the exam, this one here would probably just be worth 1. So if we have a look, the probability that the probability is late is worth exactly 15. So there. What we're going to notice is because of the nature of a probability density function, you can always have more and more accuracy. So this is not defined between any domain. It's exactly 15. So the probability in any probability density function that a number is exactly equal to a particular number is always equal to 0. So that's just something that you have to remember, and it's because you can always be more accurate. Like if this was defined as the probability that T is between 14.99 and 15.01, then we could define that. But the thing is, we don't have a domain because this is limiting to 0. All right, so we'll go to C. Basically, you just need to know that if on a probability density function, if it's asking you for a probability that something is exactly equal to a particular number, it's always 0. Okay, so the probability that Daniel is no more than 20 minutes late, given that he is at least 10 minutes late. All right, so let's check this one out. So the probability that Daniel is no more than 20 minutes late, so T is less than 20, given that he is 10 minutes late, given that t is greater than 10. All right. So using the the formula for a given probability, we can just say that this is equal to the probability that he is between these two times. So 10 up to t up to 20 over the probability that he is just over 10 minutes late. Okay, so the probability that he is between 10 and 20 minutes late is equal to 10 over 20, or 1 over 2. And the probability that he is more than 10 minutes late is 15 over 20, or 3 over 4. Now 1 over 2 divided by 3 over 4 is going to be equal to 2 over 3. All right, part D. In a school week of 5 days, find the probability that Daniel is late by at least 15 minutes at least once. Okay, now when you've got one of these at least once probabilities, so this is kind of a giveaway for me anyway, that we're going to have to, this part of the question here, that's a giveaway for me that we're going to have to use a complementary event. So basically what I'm going to do is I'm going to find the complementary event to this scenario, find the probability of that, and then take away from 1. Because you could have one time, if for this at least once, to try and find the probability of this happening, we'd have to find the probability of it happening 1 time, plus the probability of it happening 2 times, plus the probability of 3, 4, and 5. But if we just find the probability of it happening no times, then what we can do is we can just take that away from 1, because it's going to be the rest of the times. So what we're going to do, find the probability that Daniel is late by at least 15 minutes. Well, we're going to find the complement of that. So this is going to be the probability that he is late by less than 15 minutes. And 5 to 15 is 10 over 20, which is equal to 1 over 2. So that's the probability that's going to be late by less than 15 minutes. Now, if we do that for over 5 days, that's going to be equal to the power of 5, which is equal to 1 over 32. Now, once I've done this, this is the probability that he's going to be late by less than 15 minutes all week. So he's going to sort of, be a bit better at getting to school. So the probability that he's going to be late by at least 15 minutes at least 1 time is going to be 1 minus this probability. So the final probability is going to be equal to 1 minus 1 over 32, which is equal to 31 over 32. So these uniform distribution functions aren't too difficult. There's just a few classic things you've got to remember. You've got to remember how to define them, and uniform distributions aren't defined by any kind of x variable. They will just be a constant. That's why they have a uniform distribution. If we had a t in here, the distance from the x-axis or the t-axis to the function would change as t changed. So it's just going to be a constant number, and we define that over a particular domain. We also have to remember that the probability of any event exactly occurring, like t could be exactly equal to 15, is always 0, and that's because of an accuracy thing. The probabilities have to always be defined over a domain for probability density function. Now we just have to remember our formulas for given probabilities or conditional probabilities for part C. We have to remember that A given B is equal to the probability of A and B occurring over the probability of B. For D, I found that the easiest way to solve D is that you use the complementary event, and what triggers me to use that is when we have this at least one time, because there's multiple different events occurring here. When it says at least once, it could be 1, 2, 3, 4, or 5 different times. So rather than adding up all of those different events, I find the probability of it happening no times and then take that away from 1. But apart from that, it's not too complicated. I would just recommend doing a couple of them over and over and over again so you can sort of get the gist. But look, once you've got these, it's like riding a bike. You'll never forget. So I hope you enjoyed this video, guys. If you did, give it a like, subscribe to my channel, and I'll see you again next time.